If you're raising a power to an exponent, you multiply the exponents. So they give you the formula right here. It says x to the power of n, let's give you x to the power of m, raised to the power of n equals x to the power of m times n. So let's look at their example here. 5 to the third power, all to the power of 2 equals 5 to the power of 3 times 2. Which is, whoops, they made a mistake here. I'm sorry to say that. What's 3 times 2, guys? 6. This should be a 6. Oh yeah, maybe it's mad. So this is different from what we've been doing. Let me show you why. So lately what we've been doing is a multiplication rule. So sidebar here, multiplication, just to review. If we had something like 5 to the third times 5 to the second, then we would add these two exponents and we would say 5 to the fifth. But what this is saying, this is different. This is raising this entire expression to the second power. So now instead of adding exponents, this is when you would multiply exponents. I know you guys have been wanting to multiply exponents. Now we actually get to do it. And this is almost always accompanied with parentheses. So it would look like 5 to the third to the power of 2. So 5 to the third power to the power of 2. That's when we multiply those two exponents. Now we're multiplying those two. And that's 5 to the 6th power. Does that make sense? Ready to try some examples? Okay, let's do some examples here. I'll do the first couple. Well, I'll do the first one, see if you guys can figure out the second one. So here we go. We got 3 to the second. Let me get a different color. 3 to the second to the power of 5. I would multiply the two exponents. 2 times 5 is 10. So this would be 3 to the 10th power. I'll have you guys try the second one. A to the 12th, yeah. So a to the third to the power of 4. This would be a to the power of 12. Now number 3 is where it gets a little bit weird, because we have 2a to the second power, and everything is raised to the third power. And when I say everything, I mean this is being raised to the third power, but also that 2 is being raised to the third power. So what I have is 2 to the third power times 2 times 3 is 6, a to the 6th power. Do you guys remember distribution from, or did you guys do distribution in math lab? No, I guess you wouldn't have. Never mind. Distribution, an example of distribution would be, I don't want to mark this up here. Did you guys come across something like this in math lab, where you have 2 and you have to multiply everything on the inside? Okay, never mind. So this would be 2 times x, which would be 2x, then 2 times 3, so 2x plus 6. Don't worry about it. Okay, we will get there. We'll get there. Okay. Okay, so let's look at number 4. And now let's see if you guys can do number 5 and 6 on your own. So 4, you have 2 to the second power times a to the 5th power times b to the 3rd power. Everything raised to the 2nd power, which means that 2 is multiplying all of those exponents. So you have 2 times 2 is 4, so you have 2 to the 4th power. 5 times 2 is 10, a to the 10th power. 2 times 3 is 6, a to the 6th power. Yeah, so I mean, I could like try to evaluate what 2 to the 4th power is, but yeah. Okay. Oh, I'm sorry, not A, B. This should be a B. Nope. Okay, so try number 5 and 6 on your own. See you guys doing number 5 and 6. See, you're close. Close. So remember, exponent is not multiplication. It's negative 3, be negative 3 times. That's what this should be. But right now, we're worried about multiplying the exponent. We'll get to that in a second. Okay, well, let's look. Let's look, guys. So what did you get for number 5? So remember, let's just apply the exponents. We'll do the multiplication in a second. But, so we have 2. The negative 3 is raised to the second power, and a to the second is raised to the second power. Say it again. Oh, thank you. So I'm going to take that whole negative 3 right here. That one's a little bit tricky just because of that negative sign. But you would have negative 3 to the second power times a to the 4th power, because 2 times 2 is 4. So remember, when you have something like negative 3 to the second, this is the same thing as saying negative 3 times a negative 3. Don't forget that exponent is telling you how many times to multiply it times itself. So let's do that real quick. So negative 3 times a negative 3 would be what, guys? What's 3 times 3? 9. Yeah, negative. So not 3 times 3 is 9, but a negative number times a negative number is what? Positive. So I know lots of rules rolling all at once. So if we're going to evaluate that, that would be 9 times a to the 4th. And we're going to go back and evaluate the other one in just a second. But let's just finish this. Let's just do the exponents first. What did you guys get for number 6? That one's a little bit easier. S to the 6th power, t to the 12th power, yes. So let's go back and evaluate some of these. So get a calculator and see if you can figure out number 1, 3 to the 10th power. What would that be? Yes. Or you try to do that in your head, but that'd be a lot. 3 to the power of 10. Should be in the thousands, I think. Say it again. 51,000? 59,000? Oh, yeah, 59,049. Yep, 51,049. Okay, that's a pretty big number. I can't do anything with a to the 12th. Let's look at number 3. 2 to the 3rd power would be what? 8. Yep, so this would become 8 times a to the 6. The number 4, 2 to the 4th power would be what? There you go. Yep, 16. A to the 10th, b to the 6th. Yeah, so now number 1, 3, 4, and 5 are all in their simplest forms. Say it again. Well, I mean, worry about if you have a number raised to an exponent, you can figure that out. Letters raised to an exponent, we can't figure that out automatically. We need an equation, and we're not doing equations right now. Okay. What's your question on 5? Let me think about that for a second. Hang on, because I think I might have. I think I might have screwed up on number 5. Now I think about it. So yeah, so -3, yeah. So negative, since you have two negative numbers, -3 times -3, that'd be a +9. Does that make sense? Okay. Okay. Any other questions on those examples or on that rule? And like I said, don't get this mixed up with that first rule we learned about multiplication. Because if you have two numbers with the same base raised to different powers, you add the powers. You only multiply if you have a power raised to a power. And yes, you can have a power raised to a power raised to a power raised to a power, but we're not going to do that. Not until we get to calculus. Okay. So let's look at the... Oh, wait, hang on. Is this the one I was looking at? Oh, yeah. Okay. So this is the quotient law. It's kind of similar to the last one. We're kind of taking the last one, but we're kind of adding one more step. What is the last rule? Okay, I lied. There is actually one more rule after this one. Okay. So quotient law says that if you have a fraction raised to an exponent, that exponent is applied to the numerator and denominator. So for example, if they have x divided by y to the power of n, well then that n gets applied to the x and the y, numerator and denominator. So it'd be x to the n power divided by y to the n power. Their example down here, 2/3 to the 4th power. That 4 gets applied to the top and bottom, 2 to the 4th divided by 3 to the 4th, and then they simplified 16 divided by 81. If you can remember the last rule, we can do this one too. Why isn't this going up? There we go. So let's look at the examples. So I'll do the first, I don't know. I'll do number 7 and 8. How about that? And then I'll let you guys do 8 and 10. I'm sorry, 7. I'll do 7 and 9. I'll let you guys do 8 and 10. So s divided by t to the 5th power, that 5 gets applied to the numerator and denominator. So I have s to the 5th divided by t to the 5th. If the whole fraction is being raised to an exponent, the exponent goes to the top and bottom. Number 9, I have lots of stuff going on here. I have s times t to the 8th divided by r times t to the 4th. So that exponent gets applied to every single term on the top and the bottom. So s raised to the 2nd power, well that's just s to the 2nd power. T times 8, t to the 8th to the 2nd power, well that's 8 times 2, that's t to the 16th. R, there's no exponent, so I just apply that squared on the outside, the 2nd power. T to the 4th to the 2nd power, that's 4 times 2, so that's t to the 8th. Do you guys see on that one how I ended up with the t to the 6th? I have t on the top and bottom. So well, this isn't the final answer because we're going to use the division to simplify it. Since I have a t on top and bottom, what's the rule when I have exponents being divided? Yeah, I divide and I do what to the exponents? Subtract. Yep. So this would be, a simpler form would be s to the 2nd, t to the 8th divided by r to the 2nd. Okay, so try number 8 and 10 and see how far you guys get on 8 and 10. What you guys got. So number 8, What did you guys get for number 8? Yeah, so 2 times 9 is 18. And actually, I really like how Chania did this, so I'm just going to write that out. So yeah, this would be 3 times 3 to the power of 9 times 2. And then what would the bottom be? Yep. So 3 to the 18th divided by what? Yeah, 3 to the 10th power, yep. And then we can use our division rule again. So 3 to the 18th divided by 3 to the 10th, that's, what would 18 minus 10 be? Yep, so we would have 3 to the 8th power. And then you could evaluate that if you want to, but we'll just leave it there. So that would be 3 to the 8th. So number 10, there's a few different ways to do that. My gosh, they made it difficult. Okay. So just real quick, just so you guys can see how it's done. So that exponent is applied to everything on top. So I have 36 squared times 2 times 5 is 10. And then b to the 2 times 8 is 16. Divided by, well, that squared is also applied to everything on the bottom. So 4 to the 2nd power. And then 2 times 4 is a to the 8th power. B to the 5th, so 5 times 2 is 10. I might need your help on this. Can somebody tell me what 36 squared would be? I know 4 squared is 16, so I put 16 on the bottom. Can anybody calculate 36 squared? Oh my gosh. Okay, 1,296. It's okay. It's okay if you didn't do that, because I really want you guys to understand the exponents. So then again, subtraction rule, a to the 10th divided by a to the 8th would be what, guys? A to the 2nd, good job. B to the 16th divided by b to the 10th would be what? B6. And you could probably simplify, I'm almost certain you can divide these two together, but I'm just going to stop right there. Just so you guys can see the rule. Actually, you know what? Let's do it. Can somebody try 1,296 divided by 16 and see what they get? $81? Okay, so 81, a to the 2nd, b to the 2nd. There we go. Okay, so we have 2 rules, and these last 2 are going to be really short. Do you have any questions about this one? Okay, the next one is going to be the easiest rule, and actually we've already covered it. This is the last page here. 0 exponent rule. Anything to the 0 power is 1. That's so weird, isn't it? If you look at this pattern down here, under the next negative exponents, like 3 to the 4th, they expand it at 3 times 3 times 3. And 3 to the 3rd is 3 times 3 times 3. 3 to the 2nd is 3 times 3. 3 to the 1st is 3. Every single time you divide by 3. And so 3 to the 0 would be 3 divided by 3, which is just 1. So that's one rational to look at that. But either way, all these answers are going to be 1. 6 to the 0 is 1. Negative 5 to the 0 is 1. 9912 to 0 is what? What do you think? 1, yeah. What about negative 1,562,123 would be, to the 0 power, would be what? 1. Yeah. Anything to the 0 power is 1. Anything, any number with a 0 exponent is 1. Questions about that rule? Really easy, right? Okay, let's look at negative exponents real quick. That same idea of following that pattern of division will also lead us to something like this. 3 to the negative 1 power. Well, 3 to the 0 power is 1. And then I divide by 3 again, I would get 1/3. So 3 to a negative power, which just means I would flip that over. So this is what I mean by flipping over. So here they have 5 to the negative 2 is equals 1 divided by 25. Well, how'd they get that? So another way to write that, and I'm going to zoom in a little bit so you guys can see my small writing. Maybe if that's really hard time focusing when I do that. Okay. So this would be the same as saying 1 divided by 5 squared. All I did is I flipped it over. Actually, I really wish I didn't write it like this now. And that 5 squared is 25. So if I have something like 6 to the negative 2, so one thing I can do with any number is I could just put a 1 down there, right? Because anything divided by 1 is itself. So this negative exponent is just saying, hey, move me to the opposite side. Move me to the denominator. So 6 to the negative 2 is the same as saying 1 divided by 6 squared. I just flipped it over. And flipping it over will automatically get rid of that negative sign on the exponent. So again, when you have an exponent, when you have a negative exponent, all you need to do is flip that fraction over. I don't think that's even on today's practice, but I just wanted to go over with you guys. Come on. I guess I'm doing that. Okay. So like this one, 4 to the negative 5th. Well, there's an understood 1 in the denominator. So I could just also call this 1 divided by 4 to the 5th power. Same with number 3. What would number 3 become, guys, if they follow that same pattern? Yep. Well, so that's just what negative exponents do. Negative exponents moves whatever number you're working with to the bottom instead of the top. It also works the other way around. If I had 1 divided by x to the negative 1, that negative sign just says, hey, put me in the numerator. So that would be x to 1 over 1, which would actually just be x. Great question. Yeah, so let me go above that and write that out. So how they get that? So they had 2 to the negative 8 divided by 2 to the 5th, or sorry, 2 to the negative 8 times 2 to the 5th equals 1 over 8. So let's just use our multiplication rule. When I multiply two numbers, what do I do with the exponents? Add them. So what's negative 8 plus 5? Negative 3. So that would be 2 to the negative 3. And that same idea down there, that means I would just flip this over and say 1 divided by 2 to the 3rd. And so then 2 to the 3rd would be 8. So 1 divided by 8. And I realize I went through that last one a little bit fast, but I wanted you guys to have it. There's not any practice on today, but we'll go over that again when we do a practice on it. Okay, I can see by my timer it's a 23-minute lecture. You guys have any questions? And I really just want you guys to focus on the two rules. We went over the quotient rule and the power rule. Okay. I have 6g to the 3rd power times h to the 4th power. So that 3 gets applied to every term in the parentheses. So 6 has no exponent, so it would just be 6 to the 3rd power. And g to the 3rd, so 3 times 3 is 9. And then h to the 4th, 4 times 3 is 12. Does it ask you to simplify it on the back? Yes, it does. Okay. And so the last thing I do is I take 6 to the 3rd power. Can somebody try 6 to the 3rd power in a calculator? the third power? Huh? Yeah, I don't think there should be any decimals. Six to the third power? Yep, so that you have to, that'd be 216, and then I could just keep g to the 9th, h to the 12th. Say it again? Yes. We'll take this one too. Okay, help me out with number 2. What can I do in number 2? Huh? Right, yeah, the 2 gets applied to every term in the parentheses, yes. And what would that look like? Whoa, sorry. What would you say? Go ahead. So remember, there's an understood 1 if there's no exponent. So it would be 2 to the first power, y to the first power. Okay. You guys agree with that? 2h10 y2? So we're missing one thing. Yeah, so don't forget that there's that square, that 2 applies to that 2 as well. So it'd be 2 to the second power. Well, that would be right. Yeah, so because 2 times squared, you're right. 2 squared is 4, so you're right. I just want to make sure you guys knew how we got there, that's all. Yeah. Yep. So I'll leave that on the board.